looking at a quadratic in this now, technically, I'm going to add in something from before the semester break, which is a little rough, because some of you guys are like, I don't remember anything from before. But you should at least remember that this word was important, factoring, right? Factoring, with the x method, the modified x method, with all that jazz, factored form. I'm going to put that in quotes. And I think it's important for you guys to put in your notes too. Technically in the book, you can check it out right up here. It says intercept form. That's the snazzy way of calling this quadratic. They call it intercept form, and that's good, but we've also called it factored form before. Now, factored form is more the algebra way. I'm just going to put ALG for algebra. That's how I shorten your guys' class name a lot too, like on all the videos online. Algebra form is this factored form. You're just looking at the equations, but intercept form, that's a way of talking about the graph. So algebraically, we could say factored form. Graphically, we could say intercept form. Because if you guys were looking at numbers 1 and 2 that we were supposed to have done on Friday, that hopefully you filled in. Do you have your practice sheet out, Jeremy? Remember, we do our practice problems. You get 100% by working with us in class and having it to turn in, right? Our practice paper. How did we find a 0.20 and negative 20? Maybe from the equation. Just a few of you, maybe from the equation. Now remember, we have to think backwards. The signs are going to be backwards. If you want to write that note to yourself, that might be helpful, because kind of like how Caleb was saying last week, the inside is backwards. Both of these are inside. Both of them are inside. So the signs are going to be backwards. So you could have looked at the equation, but hold on, check it. Why are we calling this intercept form? What's going on at 2 in the graph, and what's going on at negative 2? When x equals 2, where's the graph hitting? The x-axis at 2. And then at negative 2, what's the graph doing? Hitting the x-axis. So why is it called intercept form? Because the x-intercepts can be seen in the equation. The x-intercepts can be seen in the equation. That's why it's called intercept form. On the graph, these little guys are going to show, mark, indicate where the zeros or where the intercepts are. Now, there are lots of different ways of naming x-intercepts, but for right now, we're keeping it basic. The x-intercepts are what we see in the factored or the intercept form. That's why it's called intercept form. Now, careful, not y-intercepts, but x-intercepts. But that wasn't the only question. Now, in both of them, you can check it then. Okay, wait a minute. Where's this hitting the axis? Oh, negative 1. Is that one of our answers? And then where else? Oh, negative 3. No, negative 4. Is that one of the answers? Yes. And you can see it in the equation also. Check it. The signs backwards. Negative 1, negative 4. Booyah. But this second question is a little different. The quiz on Friday. Remember, we had that old version of a problem. Old version, sorry. It was the version from last week. Y equals A times X minus. Well, I think I even color-coded it, but oh, I'll do it all in one color. In this form, we could see the vertex so easily, and so many of you guys, maybe a couple of you messed up on the positives or the negatives, like the signs. We made that mistake. I knew we were going to. But most of you at least knew where to find the numbers. You knew this guy went first in the vertex, and you knew this guy came second. And then a lot of you also did a great job knowing that the axis of symmetry, I'm just going to put AOS. The axis of symmetry was the same as this guy. A lot of you did a great job knowing that. But here's the problem. The axis of symmetry, the vertex, was super easy to find in vertex form. But do you see any H's or K's in the intercept form? I see a P. I see a Q. But I don't see my vertex. So check it. Axis of symmetry, super easy as long as you got the signs right in this form. How did I get this 0? It didn't come from either of these. How did I get this negative 5 halves? It didn't come from either of these. What do you guys see me doing in my work that gets the 0 and that gets the negative 5/2. What am I plugging into? What is this? I'm adding. Who am I adding?
The numbers on top.
Good, good, good. I'm adding the numbers on top. And what am I dividing? Oh, I divided. Did you see it over here? Have you made a note in your notes? There's a formula. There's a formula for how to find the axis of symmetry. Now you can technically write it on your practice page in a different colored pen if that would help you. You can write it in your notes. But there's a formula that I'm plugging in. The P and the Q comes very naturally in intercept form. The intercepts come straight out. Like in vertex form, the vertex came straight out. Depending on how a quadratic is written, we're going to be able to pull out different clues. We're going to be able to pull out different clues. Good thing, Danny, is that this is the same practice page that you had on Friday, so just grab out that, okay?
I wasn't here on Friday.
Oh, you were gone. Ooh, we have a quiz to make up too and some homework to grade. If you can, try to drop by after school today or tomorrow, okay? Oh, Caleb, were you here on Friday?
Friday?
Taking a quiz with us. You were, right? Grab out the practice page that I should have already handed out. Okay, have you guys made a note of this formula? Okay, so axis of symmetry, we can add the two intercepts together and divide by 2. Wait, isn't this like an average? If I were to tell you that I needed to average all the test scores without a computer by hand, if I wanted to average all the quiz scores and tell you guys the average on the quiz from Friday. Now, if I was to spitball, I'd probably say like a 6.5 out of 8, which is a pretty high average, especially for our class. It's a high average. But that was just me spitballing. If I wanted to find the actual average, how do you average scores? What would I do?
You
Add them all up and divide by
the number of
how many there are, right? I would add all of your guys' quiz scores up and I would divide by how many there are. How many intercepts will a parabola have? Just 2. At most 2. So check it. If I have 2, if I'm adding and dividing, I'm really just averaging them. I don't know if that would make it easier for any of you. Maybe none of you. Maybe none. But if it does help you, you could say that to find the vertex, we're averaging P and Q. Because just a couple of you, when I said average, you were like, oh, I know how to do that. Add them all up and divide by. Cool. Add them up and divide by how many? So if that helps, sweet. Let's make sure all things are together. Okay. Unless there's like an emergency, then we need to talk to you. So averaging. Add P and Q together and divide by how many? Now, there are some really weird parabolas that might not, can I give you a picture? That might not have any intercepts, but if they don't have any intercepts, it can't be written in this form. It wouldn't make sense. There are some parabolas that might be up here and might never hit. I'm going to write little exceptions. There are some exceptions, aka parabolas that can't be written in this form. We didn't have that with vertex form. Absolutely every parabola has a vertex. Absolutely every parabola can be written in that form. But there are some exceptions, sadly, to the intercept form, because if we have a parabola like this, it does have a vertex, but it will never hit the x-axis. Or another exception is a parabola like this that will only hit the axis once. If it only hits the axis once, we actually can say, this is the weird case where the x-intercepts and the vertex is at the same point. But that rarely happens. If there's only one, not two different, but if there's only one, it just so happens that the vertex and the intercept will be the same thing. It won't give us a great picture, but it will go ahead and at least let us know what's going on. This one we'll see an equation for. This one, we can't have the equation at all because there are no x-intercepts. I don't think the book gets that tricky for you guys. I'm probably getting you ready for like algebra 2, maybe even pre-calculus. But I'm just letting you know there are a couple exceptions to this form. Because parabolas don't have to have 2 intercepts, but a lot of them do. And those of them that do we can go ahead and if we can get it factored, all of a sudden we know x-intercepts, that's 2 points. We can average them to find the vertex, that's 3 points. And we don't have to go looking for any more points. Remember the quiz on Friday? When you had to graph a parabola? Didn't you get the vertex fast and then have to go find more? How many of you guys plugged in f of and you tried to go find another point? A lot of you did. I graded it. Do you remember? F of -2 or f of -3 or f of, some of you had like the wrong sign. Maybe you tried to plug in f of 1 or f of 2. But you had to go looking. But check it. If you have intercepts and a vertex, that's all you need. Intercepts, vertex, that's all you need. So if you can get these down, that's all you need. So, hold on. What's going on in number 3 and number 4? We haven't gotten there yet, right? Number 3 and number 4. Do you see how there are so many blanks and we don't have a graph? All we have is an equation? Okay, notes. Let's start and let's give ourselves some clues about how to fill in. Does that sound good? Okay, so for numbers 3 and 4, some of you are already thinking about it. We don't have a graph. Now we're trying to get a graph, which we did that in section 8.4 also. We got to the point, if you guys have your worksheets or if you looked at them today when I handed them back, we got to the point where you had an equation and you needed to get a graph. We're doing that now too, just with intercept form. So, what have we done already? Why have I crossed out axis of symmetry and x-intercept? What do you guys think? Why did I cross that out? Well, but aren't they blanks on numbers 3 and 4? So why am I not thinking that we need to talk about clues for those? Look at 1 and 2. Haven't we already talked about those? Check it. Axis of symmetry. Didn't we already write down that that's P plus Q over 2? We already wrote that down in your notes, so we've already talked about them. X-intercepts. Didn't we already write down in our notes that we know where to find those, right? Okay. So I'm not saying that it's not important. It's very much still there. I'm just saying we already did these. So let's talk about the other guys. Let's talk about the other guys. Let's do vertex. Because isn't there a special relationship between the axis of symmetry and the vertex? Yeah. A lot of you did really well on the quiz on Friday. Weren't you able to fill in this number just by stealing him? Okay, so guess what? If we're able to fill in the axis of symmetry from the vertex, we're able to fill in the vertex from the axis of symmetry. We're just kind of going backwards. Instead of starting here and going there, we're starting here and going back. So to be honest, if I were you guys, I would actually, if we were to put this in order, I would do the x-intercepts first because they're the easiest ones to find. I would do the axis of symmetry second because there's that nice little average formula. And then once you have that, keep moving up and fill in because these will be the exact same thing. Fill in the vertex. Now here's the struggle. We will have the x of the vertex, but we're not going to have the k. In vertex form, we can steal it from that number out here. But in intercept form, he's not there. So instead, we're going to have to do, if it helps, we're going to have to plug it in. Now, I'm going to probably scare you by what I'm about to write, so I'm going to make it look a lot less scary. Okay? We know that vertex is a point. You guys did great in section 8.4, knowing to plug in the point. You guys good? Bless you, bless you. We're going to steal this guy, and I'm just going to call him H, because we're going to find him by doing the formula. I'm just giving him his proper name. H is that little X guy. To find K, we're going to have to plug it in. I know. Just a second ago, it's like, you don't have to plug in anything. Okay, you do have to plug in the X of the vertex to find its Y. And just like we did in section 8.4, be careful of PEMDAS. Okay? So I'm going to write a little note off to the side. For this guy, we're going to have to plug in. Now don't worry, we're going to go do an example right away. And when we do an example, hopefully you'll be able to use it in homework tonight for numbers 3 and 4. For numbers 3 and 4. But we're going to have to plug it in. Now, domain and range. I'm going to come back to your notes. Just keep them open. Once we have a picture, I'm just going to put it right here. Use the picture, use the graph. We're going to have a graph once we get 1, 2, and 3. 1, 2, 3 should give us a graph. 4 and 5, we just have to look at the graph. And we'll ask ourselves questions in just a second. So on number 3, okay. Who's the first guy that I say we should go looking for? X-intercepts. Good. Right away we can put comma 0 because that's 1. And we can put comma 0, that's another one. Do it for 3 and 4. We already know what it's going to look like. We just need to get the numbers. Hey, we also know what the x-intercept looks like, right? No. What the axis of symmetry looks like. He's x equals. You're just setting up what the pattern is like. So we have comma 0 for one point, comma 0 for the other point. Axis of symmetry is going to be an x equals. And the vertex is a single point. Now, I know we're missing numbers, but at least we have it ready to go. Does that kind of make sense? Okay. Vertex is 1 point. We don't know it yet, but we'll find it. Axis of symmetry is an x equals. We'll find it. And x-intercepts, comma 0, comma 0. Okay. Ready? Who's P and who's Q? Who are my two numbers from the intercept form in this problem? What were you supposed to write in your notes? Signs are backwards. So you're looking at the right spot, Andrew. But Jeremy, if the signs are backwards, it's not going to be a positive 3, it's going to be a negative 3. And then Alexis, what's the other one going to be?
Positive 1.
Got him. Can you guys do number 4 then? Signs are flipped, signs are backwards. So what do you think? We'll check number 4 in a second, but what do you think the x-intercepts would be for number 4? And fill those in. Signs need to be backwards because it's on the inside. Okay, we'll grade number 4 in a second. Come back to number 3. Okay, number 3. After we do step 1, the intercepts, you could even come straight up to your graph and you could graph it. -1, -2, -3, 0. If you want, you could graph those 2 points. We already have them. And 1, 0. But we need more, right? Where's the vertex going to be? In the middle. Maybe some of you from geometry, oh, you haven't taken it yet. In geometry, there's this thing called a midpoint. And a midpoint says, I have 2. Where's the halfway point? Where's the halfway in between point? And the cool thing is you get to use the exact same trick we're using here of averaging. So averaging. My P is -3. My Q is 1. I'm adding the 2 and dividing by how many? How many are there? 2 of them. So where's my axis of symmetry? Where's the vertex going to hit? At x equals 1. Good. But is it a positive one or a negative one? Negative. Because PEMDAS would tell me technically parentheses means grouping symbols. And grouping symbols, that division sign in a fraction actually groups numerators and denominators. So it's actually showing how much, or like how advanced you guys are. You're way past the beginnings of PEMDAS because now you have these fractions, and then technically there are understood parentheses up here. -3 plus 1 would be -2. And what's -2 divided by 2? -1. Now, the cool thing is, as soon as I know my axis of symmetry, I can take it up into my vertex. Pause. Can you guys do number 4's axis of symmetry and then steal it and bring it up into its vertex? Careful. Use the P and Q from number 4, not from number 3. Add the 2 together and divide by 2. Number 4. Who are your intercepts? You gotta average them. Add the 2 together. Divide by 2. Bring it up into your vertex. Now, I think I've given you some white space off to the side for 3 and 4, right? Just a little bit. The reason I gave you white space, or even down below at the bottom of the page, you can do that too, there's white space. Because we know the x, but we don't know the y. And what did we write just a second ago for how to find the next part of the vertex? Plug it in, plug it in. Plug what in? This guy. Plug him into where? The function. Now, I just made my function disappear because I went down too low. So our vertex x is -1. We need to go plug it into f. If you have room, you can do it up here with me. If that's too squishy, you can come down here at the bottom. But I want to go ahead and take my -1 and say, I need the y value. And so I take my vertex. I have my 2 other points. I just need the vertex, then swoop, for the most part, there it is. So I'm going to go ahead, come into the function, and remember, once I have an x, I plug him in every single x spot. So -1 plus 3 and -1 minus 1. For some of you, this is so much easier even than plugging into this form, because this form had a lot more PEMDAS, parentheses, and exponents, and multiplying, and adding. This one, I think it's just parentheses, multiply, right? Parentheses, multiply. But be careful of your addings and your positives and your negatives. Some of you make mistakes with them. Okay? So if it helps, remember, we can make every subtraction into adding the opposite. If it helps, we can actually think of this subtraction as adding an opposite. Subtracting always is and always will be adding the opposite. Some of you, this will be easier on your brains. What's -1 plus 3?
2.
Parentheses. We have more parentheses. What's -1 plus -1? Or -1 plus 1? -2. Could you have gotten there without rewriting the minus? I don't know. But I have my +2. I have my -2. PEMDAS says after parentheses we multiply. -4. So what's my vertex point? -4. So now I can go to my -1, -1, 2, 3, and 4. And guys, does it make sense that this positive quadratic is going to be concave up? Does that make sense? Just a few of you on the quiz didn't double check to make sure it made sense. So your negative quadratic ended up being the wrong way. A couple mistakes in plugging in maybe, but don't worry, partial credit was all over that quiz. You guys will probably get it back tomorrow or the next day. We have a few absent people that need to make it up. But it didn't seem too bad, did it? Can you guys try to graph number 4 then? Now remember, you should have the x of the vertex. Can you plug it in to find the y of the vertex? And then can you try to graph all 3 points and connect? We'll talk about domain and range in a second. But to make your parabola. Max, what's up, bud?
I'm confused how you got to the 3.
How I got the, which one?
The vertex one.
This guy?
The top part.
Oh.
Top 2 points.
For this one, right?
Yes.
Okay. Remember, I'm trying to plug in to my function.
Okay, yeah.
So I'm trying, I have this x value by just stealing this number.
Yes.
Right? But I needed to find my y, and to find my y, I can always take the x back and plug in.
Okay.
So I plugged into f of -1, and I plugged into the x spot wherever it appeared. So that -1 took the place of x there, and took the place of x there, and then it was a grand old PEMDAS to get to the final y. Does that kind of make sense? So I had to replace it into the x and then simplify.
Okay.
Yeah. Adrian, do you have a question too?
Almost that.
Oh, let me see. Oh, some of your copies got a little funny. Can you guys double check your number 4? Is it negative parenthesis x minus 5 parenthesis x plus 1?
Yeah.
Plus 1. That's okay. Sorry if those of your copies that got a little funny. Can we go peek and see how you're doing on number 4? Is that cool?
Yes.
Okay, let's see. So, you guys should have started with your x-intercepts, right? And we were able to do 0 for both. Got him. Did you come up and did you do the backward signs to get 5 and -1? Good so far? For the axis of symmetry, did you steal both of those p's and q's, both of those intercepts, and did you add them and divide by 2? and do PEMDAS to get 4 over 2 is 2. Did you steal that 2 and make it the beginning of your vertex? You guys are rocking it. Good so far? Okay. Where could you have made a mistake? I'm sure there are a couple that are like, you could have messed up the signs, right? It's easy to forget backwards, so a negative means a positive means a negative. That's hard. You might have messed up PEMDAS a little bit and accidentally written the wrong number of 5 plus negative 1. It's 4. But otherwise, hopefully, so far, so good. Now, hold on. We need to plug in who this is, right? Okay. How do we get that y value if we know an x value? Plug it in, plug it in. To who? To this function now. Now, I know this isn't written in function notation. I did y equals. If it helps you, for once, you might actually rather the function notation. A lot of you would rather the y, but maybe this time f of x is easier. Either way, we just need to take this equation and get that 2 plugged in to remember the x values, right? And then we have to be super careful with PEMDAS. So then we would have a negative on the outside. Isn't it 2 minus 5 and then 2 plus 1? PEMDAS says parentheses. What would the first parentheses become? What would the second parentheses become? Now, you guys might see a pattern right here. Just a heads up, it's not always that way. So please don't try to memorize something. It's not always 1 is one number, 1's the opposite. Just do the PEMDAS. Whatever happens, happens. Next would be, oh, we've done parentheses. Exponents? No. Multiplication. Technically, I guess multiplication, we would go from left to right. We would do a negative times a negative to be a positive. But even if you did multiplication, then multiplication, you're still okay. Isn't it going to be a positive 9 no matter what? So positive 9 no matter what. Positive 9 goes in. Did you guys graph all of these pieces to get 1, 2, 3, 4, 5, 0? And to get negative 1, 0? And then your 2 goes to 9? Does it make sense that this parabola is going down? Yeah, it's a negative, right? It's a whole negative quadratic. So it makes sense he's going down. What's the one last 2 blanks we need to fill in, guys? What's missing on 3 and 4? Okay, and we haven't written tricks for those yet, right? So let's go back to where I was taking notes. Let's talk about domain and range. 2 words that we've already seen. And technically, if it helps, remember domain X, he sounds like a medicine, rangy, cute little rangy. Anyway, domain talks about x's, range talks about y's. If we're looking at the graph, remember, domain is going to say how far left to right. Whereas range says how low or how high. Now the nice thing is for parabolas, this is kind of a trick, for parabolas, these up-down dudes, the domain will always be that nifty R. And what is that nifty R? All real numbers. So right away, for 3 and 4, you can say all real numbers for domain. It's always that way for any up, any down parabola, because they're going to keep on expanding. They're going to keep on going left and right. So that's easy, cheesy for both of these. Domain is all real numbers. The range is what's hard. Because if we have a downwards parabola, it can only go so high. And that k from up here, that f of h, y has to stay lower than that k. If you want, you can write the little, oh, remember, that dude's the k. Remember from back then? The k of the vertex. I know it's not written like this, but this is still true. There is a k. But if it's the other way, then we can say, well, y can only go so low. And how low can y go? Well, he has to stay above the k. Did you guys write down those 2 clues? If you have that, now it's as easy as saying, I know the y, and I know the negative 4, but look at the picture. Is it going to be above it, or is it going to be below it? That negative 4. Above or below? Above. So put the greater than or equal to. If you have the graph, just use your logic. Y has to stay above that negative 4. But look at number 4. Domain. All real numbers. Always, always, always. Good, Max. All real numbers. You can write it with words, or you can write the snazzy double R. All real numbers. I'll put it in parentheses in case it helps. But for the range, can't we do the y and the 9 right away? Is it going to be going above that 9 or below that 9? It's as easy as that. Less than or equal to. Hey guys, check both sides. We did all our practice problems, yeah? What does that mean you're ready for? If you want, you can write down homework right now on your practice page, or you can take a picture with your Renbud from your Google Classroom. All the above. I think you guys are primed and ready to go. Sound good? Awesome. Keep this practice page close. Keep your notes close with those little hints about how we filled in each of those blanks. You guys are ready to rock it. Hang out for 30 seconds and I'll let you go. Sound good? Alright guys, get out of here. I'll see you later. Good job. Rock that homework, okay? Come tomorrow with questions.